From the database server's perspective, the PHP application is a client of the database. The queries we've been writing and sending to the database are referred to as ad hoc queries. We write the entire query on our side in the application and send that query to be executed on the database server. Well, we need to take precautions when doing that, especially if we're including user input in the SQL commands that we're sending to the database server. We must prevent SQL injection attacks by sanitizing and validating the data provided by the user. Again, never trust user input. Another approach is to execute code that already exists on the database server. This code that already exists on the database server is referred to as a stored procedure. It is a SQL statement that has been written and stored, ready to be called on the database server. There are a lot of benefits to stored procedures. From a DBA perspective, a stored procedure is safer and faster. Using a stored procedure only requires that we use a new keyword, call. We're going to call some procedure that's already stored on the database server and pass it whatever information it needs to give us the data that we want from the server, or pass it information that the procedure needs to insert or to change data on the database server. If we're passing a parameter that's based on user input, we still must sanitize and validate that data before calling the stored procedure. If a stored procedure is returning data to us, then we want to assign that return data to some variable in our application code. Well, there are a lot of uses for databases in a web-based application. One of the most powerful uses is in the ability to build a dynamic web-based application, an application that is driven by the database. Within our PHP code, we construct the pages to be displayed to the user based on content within the database. By using a database to make our web applications dynamic, we're able to ensure that our content is fresh and current. Also, on the other side, using a database simplifies content management. Now let's go look at some code. This example is going to provide a quick demonstration of how to use a database to store a web application's content, retrieve that content, and dynamically display the website for a visitor. So first, on line 26, we include a header file that contains the HTML to generate the header section of each web page. And on line 42, we do similarly with the footer section. So this gives us two files that standardize those sections of every web page on this website. Content for the div areas on the individual web pages is retrieved using the getContent function. The getContent function requires three arguments: the website name, the page name, and the div ID name. Given those three arguments, getContent retrieves the HTML and other content associated with that div tag on the web page. The entire index PHP page for this website is driven by these few lines of PHP code. All of the content is contained within the database. The website content can be updated using the administrative tool to manage the content on the database. This code does not have to change to update the content of the website. So the getContent function is composed of a SQL statement and a database query. The result variable contains the content to be displayed on the web page as stored in the database. Here's our header file. So the header file has the content that will be displayed on every page of the website. Likewise with the footer section. All of the content is driven through the database from a single function call, in this case to get content, which is then displayed with an echo statement. This database represents a very simple content management system with an administrative toolbox to manage the content within the database, but still a very simple content management system. These few lines of code and the calls to the database to return the content generate this output, which can easily be updated and maintained by changing the values in the database.